For a prehistoric human, survival was calculated in brutal daily margins of calories. Every ounce of energy expended in freezing environments had to yield a direct biological return, usually in the form of food or shelter. Crafting a spear tip is a practical investment in that survival, but hollowing out an animal bone, precisely measuring intervals, and drilling perfectly circular holes into its surface takes days of meticulous, high-focus labor. In a world where starvation and exposure are constant threats, dedicating massive amounts of time to carve a delicate object that cannot hunt, harvest, or heat a cave appears biologically irrational. Blowing air through a carved bone yields no physical protection and provides zero protein. Because these objects offer no immediate biological advantage, our ancestors must have recognized that they solved an entirely different, yet equally urgent problem. This diagram shows a physiological cross-section of the human throat. Hundreds of thousands of years ago, a horseshoe-shaped structure in the neck, called the hyoid bone, shifted downward. This tiny anatomical relocation expanded the vocal tract, granting early hominins precise mechanical control over the sounds they produced. By pushing air through this newly configured space, early humans could modulate pitch and tone. Long before the invention of formal language, they relied on these vocalizations to share information, signal danger, and forge crucial social bonds within their tribes. Eventually, they discovered a way to project and manipulate these sounds outside their own bodies. By repurposing the naturally hollow bones of scavenged birds and hunted animals, they built devices that mimicked and expanded upon the acoustic capabilities of the human throat. These flutes represent some of the first specialized tools designed specifically for human connection. They allowed our ancestors to anchor their social groups through shared sound, a priority that stood alongside their need for food and fire. In the caves of modern-day Germany and Slovenia, archaeologists have unearthed instruments dating back 40 to 50,000 years. These were crafted from the massive femurs of cave bears and the wing bones of griffin vultures. The makers horizontally scraped each finger hole. This specific technique ensures the sound acts as an aperture, originating directly beneath the player's fingers. Some specimens even feature carefully carved V-shaped notches at the top, acting as a beveled edge to steadily direct airflow. Working with hollow bone is difficult, but the Ice Age environment presented even harder materials. To make an instrument from mammoth ivory, a maker had to take a solid, dense tusk, split it lengthwise, hollow out the two halves, and then bind them back together with a completely airtight seal. Enduring the grueling physical labor required to split and seal dense ivory suggests a high degree of social utility. In the lethal cold of Ice Age Europe, creating complex acoustic tools helped bind small tribes together, building the communities necessary to survive the climate. 9,000 years ago, at the Neolithic site of Jiahu in central China, instrument makers selected the wing bones of red-crowned cranes. These bones were naturally hollow but remarkably resilient, making them ideal for complex, permanent modifications. Producing a raw sound requires a simple cavity and a mouthpiece. Organizing those sounds into a deliberate, repeatable sequence of pitches requires an advanced understanding of acoustic physics. This diagram illustrates the structure of a 7-hole Jiahu flute. Beside the 7th hole, the maker added an extra, tiny drill mark. This specific, calculated alteration was designed to raise the pitch of that single opening from a G-sharp to an A. Because of that minute adjustment, the instrument is capable of playing a structured sequence almost identical to a modern Western 8-note scale. Handcrafting an instrument is one process. Playtesting and actively correcting its intonation is another. The Jiahu flutes demonstrate that prehistoric Chinese communities actively calculated mathematical harmony, establishing melody as a refined, permanent part of their culture. Between the 1st and 3rd centuries CE, instrument makers in Oaxaca and the pre-Columbian Andes crafted flutes from deer bone. These models introduced a new feature, a hole positioned on the back of the instrument specifically for the thumb, allowing for more complex fingering patterns. They also embedded intricate visual narratives directly into the bone. The surfaces feature elaborate carvings of skeletons, human faces wearing masks associated with rain deities, and speech scrolls, symbols used to depict the movement of air, breath, or song. makers intentionally perforated the inner tubes to create multiple diameters along the shaft. When blown with force, this geometry produces multiphonics, where two distinct dissonant tones are heard simultaneously. The exterior carvings match this intensity, with finger holes aligning perfectly with the eye sockets of the etched figures. These flutes were often played together in massive consorts, purposefully avoiding consonants. The overlapping friction of dozens of multiphonic instruments playing together was combined with hyperventilation to induce altered states of consciousness. By engineering an acoustic environment of overwhelming physical dissonance, these societies built a tool to impersonate their deities, using intense sound to bridge the gap between the human world and the divine. From the dense ivory of Ice Age mammoths to the hollow wings of Chinese cranes and the carved deer bones of Mesoamerica, the specific materials varied wildly across thousands of miles and tens of thousands of years. Yet, despite completely disconnected geographies and timelines, every one of these cultures dedicated extreme physical labor and precise mathematics to the exact same endeavor. The flute functioned as a sophisticated technology adapted by its makers to lock communities together in harsh climates, to decode mathematical harmony, and to project the voice of their gods. Caloric efficiency keeps a body functioning, but a group of humans cannot operate without a shared social and spiritual framework. The presence of these instruments across such vast timelines indicates that organizing sound has been a constant priority for our species, as enduring as our need for food or shelter.